Algebra, we are kicking off the 23-24 school year with CO1. We talked yesterday about what's going to be in our unit, and we're kind of starting with the foundation, right? Starting with the basics. It's not the most exciting thing in the world, but it is important so that when we use terms like rational, irrational, perfect squares, order of operations, then you kind of have a sense of what we are talking about, right? Like I said, there will be some new stuff in this unit as well, particularly CO5, scientific notation, CO8, and arithmetic sequence. But generally, these are kind of about the basics, the nuts and bolts, the foundation of the math, and that's where we're going to start. We're going to start with CO1, okay? So these little symbols that we have here, if there's any key terms, definitions, those are those wise old owls. No, they're not frogs. They're wise old owls. And that's going to be stuff that we are going to be defining. Can wise old owls go on a help sheet for a test? Yes. Okay. Then you get these key points. Key points are important things to remember. Can key points be written on a help sheet? Yeah. Yes. Then you have the Mr. Happy Pencil. And the Mr. Happy Pencil is going to be your homework. Example problems / homework. Can Mr. Happy Pencil section items go on a help sheet? No. They cannot. Okay? But typically that's going to be your, one pager today. We really do start. Yeah, nice. Okay? So whatever we don't finish in class will be assigned for homework. I don't remember if this class I've talked about the number game with you before. But a reminder on homework, I don't grade it on accuracy. I grade it on completion. Okay? Homework is practice. Right? Just like those of you that are in the play. You got your scripts yesterday. You're not supposed to know them the next day perfectly. You practice them, right? If you're at rehearsal and you make a mistake with your lines, it's okay. Okay? If you're playing basketball or football and your coach just taught you a brand new play, and as you're practicing it, you make a mistake, it's okay. You're supposed to. You learn from it, right? If that mistake isn't fixed before the game, or you don't learn your lines before the actual play performance, that's a problem. Kind of like if you don't understand the homework before the test, that's a problem. But I don't grade on accuracy, simply on completion. And if all of you do participate in completing your homework, then we can play the number game. Did I talk about that? No? The number game, we play it whenever everyone does the homework in its entirety, and if you win the number game 3 times, then I bring in donuts or cookies or brownies or something like that as a reward. So am I bribing you? Yeah, you can say I am, but it's worth it. Okay, I want you to do the homework. So anyway, CO1. I can classify a number as rational or irrational. These might be words that you're unfamiliar with, which is why they are definitions. Okay, but what can you tell me about rational versus irrational numbers? Actually, I take that back. These are familiar to you because last year in pre-algebra CO1, we talked about whole numbers and integers and rationals versus irrationals, right? Okay. It was a year ago, so you know. Yeah. Hugo.
Rationals can be expressed as the ratio between 2 integers, but irrationals can't.
Say more about that. Those were big words for me.
If it could be like written as a fraction.
Ah, there we go. Yeah. A rational number is any value, positive or negative, that is a fraction or decimal. And who remembers what the conditions are for a decimal to be considered rational? Gus?
Has to end or repeat.
Very good. A decimal that ends or repeats. Okay? A decimal that ends or repeats. How do you show a decimal repeats? What's the symbol for that, Mario?
It's like the little line over the two of the decimal.
Yeah, so if you got something like, at the fraction 1/3, right? 1/3 of the decimal is 0.33333333333 goes on forever. You could write that as 0.3, and then that line over the 3 showing it repeats forever. Okay? That would be considered a rational number. Even though the decimal doesn't end, technically, because it repeats, it does fall into that rational. Right? Who shared that piece of information? Mario? Very good. Okay. An irrational number. What is an irrational number? Yeah, Emily. A decimal that does go on forever without repetition. Okay. An irrational number is a decimal that does not end or repeat. Decimal that does not end or repeat. Give an example of an irrational number. Pi, right? Here's the first 100 digits here, but computers have calculated out to billions of places, and it does not end, it does not repeat. And because pi is such an important number in mathematics, it actually just gets its own symbol, right? We don't have to write out the whole thing or even part of it, just the symbol pi. But when you do use pi as a decimal, you typically abbreviate it to 3.14, which 3.14 by itself would be rational, so it does end, okay? But that is only an abbreviation of pi, which is irrational. What else? How about 9.815572 0, 4, 6, 1, 9, 0, 4, 6, right? And on and on and on and on and on. Okay? How do we show, because I'm going to run out of room here in my page, how do we show that that decimal does continue without repetition? Exactly like putting like 3 dots on there, right? It's like that text message that if you're responding to a question from your parents, or like you were supposed to do something after school, and your parents are like, "Did you buy the milk?" And you respond like, "Yes, ... like maybe I bought the milk and a whole bunch more, or maybe I didn't buy the milk and I'm going to go do it now, but I do it, right? The ... There's something more going on there, right? And it continues on. This kind of ringing the bell from last year? Okay. So rational versus irrational. Any questions thus far? Very well. So then we also kind of introduced perfect squares and non-perfect squares, which we'll actually cover in depth tomorrow. But what is what do I mean by a non-perfect square? So it says the root of any non-perfect square will always be irrational. What does that mean? Non-perfect square. I gotta move this into it. Ellen. Okay.
Well, if it's not a perfect square, you can't say 36. You can do 6 times 6.
Right. So it might be easier to start with what is a perfect square, right? A perfect square would be a number like 36, because if you take the root of 36, what do you get? 6. Remember, the root means what number times itself, okay? And where that comes from is that if you have 36 dots, can you make a square out of 36 dots? Yes, you can. 6 by 6, right? Another example of a perfect square would be 9. If you've got 9 dots, you can make a square using 9 dots. What's an example of a non-perfect square? Less than 10, just to make my drawings fit. Non-perfect square, less than 10. 3. Can you make a square out of 3 dots? No. Okay. So the root of 3 would be a non-perfect square. How about 8? Can you make a square out of 8 dots? that's a rectangle, isn't it? A 4 by 2, because 4 times 2 is 8. But I can't make a square out of 8 dots. So therefore, the root of 8 would also be a non-perfect square. And if you were to take the value of a non-perfect square in your calculator, those that do take your calculator out, just so we can practice this. This is a good time to introduce some of the buttons on your calculator. And for my purposes, I'm going to be explaining this using this calculator, which was the one on the supply list. If you have a different calculator, that's fine, but you might have to figure out your own way to do it based on the buttons that you have. I can probably help you. I'm familiar with most of them, but there are some out there that are a little bit tricky. But anyway, so on that calculator, if you look for the 7 key, we kind of do it down here. The 7 key, kitty corner from that is the x squared button, right? Or is it right next? It's right next to it. And right next to the 7 is the x squared button. And above the x squared button, on the calculator itself, not on a button, is the root symbol. It's probably in yellow or light purple, or depending on what color you have. Okay, because then the next button above x squared is that little caret, right? But painted on the calculator itself is the root symbol, which means since it's not on an actual button, to use it, you have to press the shift key first. Kind of like on a computer, when you want the $sign, you have to press shift and then hit the 4 button to get the $sign. Similar thing here, okay? And on your calculator, the shift button is way in the top left corner. It says second. Okay, that stands for second function. Is that what you're going to say? Perfect. Okay, so you're going to push that button first, then you're going to press the x squared button, but in your calculator, it's not going to give you something squared, it's going to give you the root symbol with a parenthesis. Okay, and then I want you to get that far, and then type in 8 and close your parenthesis. We're going to take the root of 8, right? And this is where I get to walk around. If anyone's having any issues, we get to solve them, because the last thing you want to have happen is you need to take the root of 8 and not quite be sure how. Anyone having issues?
No.
Good, you got it. You got it. Anybody over here? James? Whoop, that looks a little long. Yeah, so second function, and then press the x squared button to get that root. Good. Anybody having issues? Okay, and what is the value of the root of 8? Emmeline, read it to me, please. 2.82842712. Oof, that's a beast. It's nasty. Okay, does that decimal end? Well, it ends in your calculator because why? Because you're running out of room, right? The calculator is a great tool, but it's limited. Okay, it can't give you the entire value of this root of 8 because it just runs out of space. So, thus, the key point here is the square root of any non-perfect square will always be an irrational number. This decimal actually does not end. It does not repeat. It only appears that way because your calculator runs out of space. So what I don't want you to do is on a test, type in the root of 8 and think that this is the end of the decimal. It isn't. Right? It's a non-perfect square, and so it's always going to be irrational. All right, questions on that? Okay. Yep. What? You say something? No. Okay. So your homework then is to run through these examples here and basically tell me, is it rational or irrational, and then explain why. I'm not looking for a full paragraph reasoning or even a sentence, right? Just a couple words. What I don't want to see on your page is a whole bunch of, R, I. Tell me why. Okay? Why is it negative 19.7 rational? Decimal ends. All I need to see there is ends. Okay? Why is the root of 36 rational? What is the root of 36? 6, right? Equals 6, which obviously doesn't go on forever. 16 30-seconds. Why is that rational? Aiden.
Because if you divide 16 by 32, it's just 0.5.
So 2 reasons, right? Number 1, it's a fraction. And if you do divide 16 by 32, it's equal to 1/2 or 0.5. And 0.5 clearly ends. Okay, so I'm not looking for a whole novel as to why. Just give me something more than just the letter. Why is pi irrational? Never ends. Right. Doesn't end or repeat. Okay? Okay. Then the section below that, answer each question. Oh, 1 page is that. Write the value of 9 3 ways. As a negative integer, a fraction not in simplest form, using an exponent, and using a square root. So I give you 4 options. You need to choose 3 of them. Write the value of 9 3 of those 4 ways. Because as we've seen, like root 36, that equals 6. This has a value of 6, even though it doesn't look like 6. But the root of 36 has a value of 6. This is a value of 1/2 or 0.5, even though it doesn't look like 1/2 or 0.5. Okay? So there are different ways to write values using these different techniques in mathematics. That's what I want you to practice here. In our number system, are there more rational numbers or more irrational numbers? And explain why. And lastly, for review, describe what a whole number is and what an integer is. Perhaps, since obviously all of you kept your binders from last year.
I
did.
Good. You can look, CO1 from pre-algebra is where you can find those definitions, or I'm sure your friend Alexa or Siri could also assist you with that one. Okay? What's up? Well, sure. Yeah. Yes. I have not done the world today, so don't bring it up. Questions, comments, concerns, complaints, comments, congratulations, or criticisms? Thank you. Appreciate that. Okay. Now we get to practice the outro. Okay. When I'm done, I will say, that's how you math, and you say, don't forget to like and subscribe. All right, and you have to sell it. Okay, remember, 300 subs. That's the goal. I actually, when I threw out the 8th grade, I lost some. Some that were subscribed from last year desubscribed, unsubscribed. Because I don't know, 8th graders, it's like we get along great 7th grade year, then as soon as they get to 8th grade, it's like, no, anti-math, anti-Schultz. I don't know what it is. I think Spiel's brainwashing or something. Anyway, so that's how you math. Don't forget to like and subscribe. Practice round. That's how you math.
Don't forget to like and subscribe.
That was brilliant. For realsies now. That's how you math.
Don't forget to like and subscribe.